Good morning, fourth graders. Mr. Schroeder here. I set up a YouTube account this morning, so maybe I could upload some videos to you guys via email. So I'm hoping that you're checking your emails. I'm going to give it kind of a practice go today of what a lesson might look like. I know school doesn't actually start till Monday, or the distance learning doesn't actually start till Monday, but I thought I'd give it a test run for those of you who are at home looking for something to do today, and we'll get rolling with it. So I'll start every lesson kind of how I did before. Students will be able to add and subtract fractions. This is a review skill from a couple of weeks ago, but I thought we could use a review on it, okay? So the first thing I want you to keep in mind is that when we add fractions, the most important thing is having common denominators. Like all of you know, this would be an easier problem because we have 8 and 8 as the denominator. And when we have common denominators, these problems become even easier because we just add the numerator. So in this case, it would be 3 plus 4 gives me 7. And then you keep the denominator the exact same, 7/8. On problems where it comes to having numerators that exceed the denominator, like 5 plus 4, and that might be an improper fraction, 9/8, obviously then we need to remember to reduce and say 8/8 makes 1 whole. 8/8 would be 1, plus another eighth would make 9/8. So we have 1 whole and 1 extra eighth. I would consider that to be a little bit easier of a fourth grade problem, but after showing you that, I'm going to move on to what I wanted to talk to you about today. I'm going to try to keep these lessons pretty short and then give you some time to do it on your own too, maybe with a whiteboard. So if you don't have that, you might want to pause the video, go grab a whiteboard, Expo, and eraser, and then come on back to the computer screen. But here's another example of a problem you might see. So if we had 1/3 plus 2/6. In this case, obviously something's wrong, so we look at the denominators and we know that they're not equivalent. So we're going to have to go ahead and change these, or change one or the other to make sure that we have common denominators or the same bottom digit there. So we can either try to make a 3 into a 6 or a 6 into a 3, and either one will work in the situation. I'll roll through both versions of that. If I want to make a 3 into a 6, remember we can only times or divide. But I'm going to have to times, obviously, to make a 3 into 6. 3 times 2 gives me 6. And whatever I do to the bottom, I do to the top. And 1 times 2 gives me 2. So these are what we call equivalent fractions. 2/6 and 1/3 are the exact same thing. I told you a story earlier on about my Uncle Terry, and we also call him Bear. Well, this is my Uncle Terry, this is my Uncle Bear. Same guy, different name, right? In this case, now I don't need the 1/3, I could actually get rid of that. And now I have 2/6 plus 2/6 gives me 4/6. And then you could, for those of you who are a little bit more advanced, you could reduce that. What does 4 and 6 have in common? They have the factor of 2. Divided by 2, you get down to 2/3, or because we made another equivalent fraction by division. 2/3 would be my overall best answer. I can make either one of these answers would be acceptable though. Okay, I'm going to run through the other way we could have done that too using division. So it's 1/3 plus 2/6 was the original problem. If I wanted to, instead of changing the 1/3, I could change the 2/6 with division. But once again, I have to find common denominators, and I'm going to have to use equivalent fractions to do that. So fractions that mean the same thing. If I turn the 6 into a 3, how did that happen? I can only multiply or divide. I'm going to have to divide in this case to make a number smaller. 6 divided by what gives me 3? I know that that's 2 because 3 times 2 gives me back to 6. Divide, whatever I do to the bottom, I do to the top. Divide by 2 again, and you get 2 divided by 2 is 1. So now you have these as equivalent fractions. 2/6 is equal to 1/3. I can get rid of my old fraction, because now I have an easy problem. 1/3 plus 1/3 is 2. Keep the denominator the same, thirds. Good thing about doing it that way is you already have a reduced final answer, which was nice too. Okay, I'm going to give you an example problem to try on your whiteboard now, and then maybe you want to hit pause when I'm done writing it so you can try to do it on your own. Okay, how about if I had 2/4 and I was going to add 3/8. On this one, I'll give you a hint. I'm going to change this fraction to an equivalent fraction with a denominator of 8. Why don't you give that a go? You can push pause on the video now. Hopefully the light's not glaring on this board, but give it a pause and then go ahead and try this one on your own. Okay, now if you're done with that problem, I'm going to move this over to become an 8 by timesing by 2. Whatever I do at the bottom, I do at the top. 2 times 2 is 4. And notice we've talked about a half a lot, because 2 is half of 4, so that's half, like half of a candy bar. If the candy bar is broken into 4, 2 out of the 4 would be half a candy bar, and 4 out of 8 would be half of a candy bar as well, so those are equivalent. I don't need my old fraction anymore. 4/8 plus 3/8, 4 plus 3, add the numerator, gives me 7, and the denominator being still 8. So 7/8 is my total answer. Okay, I'll do one more example with you, and then I might wrap this lesson up. I'll try not to make these lessons too long for you. How about if I have 2/3 and I'm subtracting, let's say, 3/12. Okay, go ahead and pause the video if you would and give this one a shot. How are you going to change this? Could you make a 3 into the 12? Would that work? Or would 12 becoming a 3 work better? You have to decide. Okay, and if you've paused it, you're probably done by now. In this case, I'll just start by making a 3 into a 12. That's timesing by 4. 3 times 4 equals 12, because 12 divided by 4 gives me back to 3. Whatever I do to the bottom, I do to the top to make equivalent fractions. 2 times 4 is 8. And now I don't need my old fraction anymore. 2/3. I have the equivalent fraction 8/12 minus 3/12. Just like in addition, you just work with the numerator, keep the denominator the same. So 8 minus 3 gives me 5/12. And we've talked about prime numbers. 5 being prime would make it, you can't reduce that fraction and you would be done. Now, I wanted to look at what would happen if I tried to turn that 12 back into a 3. Okay, so I'll go back to the original problem of 2/3 minus 3/12. I will get the same answer, but you'll see that this way might not work. Okay, so if I want to make 12 into a 3, I can do that using division. 12 divided by 4 gives me 3, because 3 times 4 gives me back to 12. But when I go to the top now, and I say whatever I do to the bottom, I must do to the top, divide by 4, and it is not possible. You can't have 3 divided by 4. Well, you could. It would be 3/4, but it would look pretty silly to write 3/4 thirds down, so you can't do that version on this one. So you just got to kind of be a little bit creative when you're thinking, what common denominator can I find? My last example I'm going to give to you, and then maybe you can make up your own problem on your whiteboard, is a situation where you might have to change both denominators in order to find the answer. For example, if I use 1/3 and I'm going to add, let's just say 2/4. Keep them simpler for right now. I notice that a 3 can't become a 4 no matter what I times it by, and a 4 can't become a 3 no matter what I divide by. So I have to look at this problem and say, well, what common, we've talked about the word multiple, what number does 3 and 4 both fit into? 3 and 4 are both factors of what multiple? What number could I fit into? So I might check at 3 first and just do all the multiples of 3 until I know that there's one 4 can fit into as well. So I have, excuse me, I'm trying to make it so it doesn't glare on your screen. 3, 4 doesn't fit into 3. Does 4 fit into, if I double 3, 6, the next multiple, 3? Nope, 4 doesn't fit into 6. Double, or triple 3 and you get 9. 4 doesn't fit into 9 either. Well, 3 times 4 gives me 12. Does 4 fit into 12? Yeah, because I just said 3 times 4, 3 groups of 4 will make 12. Well, whatever I do to the bottom, I do to the top. If I times by 4 on this side, I have to times by 4 on the top here, so 1 times 4 is 4 12ths. These are equivalent. I have to work my way to this side and do the same thing with the 4 to make it a 12, but I didn't times by 4 to make 12. 4 times 3 will make 12. Whatever I do to the bottom, I do to the top. 2 times 3. 2 times 3 is 6. 2 fourths, 6 twelfths, both equal to a half. 6 is half of 12, 2 is half of 4. These are also equivalent. These are equivalent. Now if I just get rid of my old answers, or my old fractions, excuse me, and I add 4 plus 6 gives me 10, and keep the denominator the same, 10 twelfths. For those of you who really want to get really advanced with it, you can even reduce what fits into 10 and 12. Oh, 2. If I divide 10 by 2, I get 5. If I divide 12 by 2, I get 6. The both acceptable answers, which are equivalent, would be 10 twelfths, or the best answer would be 5 sixths, because you reduced and found an equivalent fraction that was the lowest you could possibly make those numbers. Okay. Now I'll give you some time to maybe, or I might just wrap this video up. Make sure if you have any questions, you let me know, but I want you to create your own, but I want you to use the denominators 10 and 100. You can make a subtraction problem or an addition problem, but remember, if you subtract more than you start with, we haven't talked about negatives yet, so make sure that this fraction is bigger than this fraction before you subtract, okay? Have a little fun with it. Maybe teach a brother or sister at the same time. It'd be kind of fun too. So until then, guys, I'll see you next time. Thanks. Bye.